In section 4.2, you're going to be multiplying matrices, and as you notice here, I've written down that matrix multiplication is not like matrix addition and subtraction. And the reason why I do that is because every year I have students who try to multiply matrices like you add and subtract, and matrix multiplication does not work that way. So in section 4.1, you multiplied a matrix by a number called a scalar. In section 4.2, you will be multiplying two matrices together, and the setup for multiplying matrices is different, and I've circled that in red just to emphasize that. It's different than the setup for adding matrices. When you added and subtracted two matrices, the dimensions had to be the same. That is not the case with multiplying matrices. Warning. This is just a reminder, when you write the dimensions of a matrix, you must list the number of rows by the number of columns. And rows go this way, columns go this way, like the columns on a house. All right, to multiply two matrices together, the columns of the first matrix must be equal to the rows of the second matrix. Now, what that means is if you write the dimensions of the first matrix next to the dimensions of the second matrix and you circle the two inside numbers, if they are the same, and that's the inside numbers, you can multiply the matrices together. So let's take a look here. Well, first let me tell you about defined and not defined. We talked about that with addition. If two matrices can be multiplied together, we say their product is defined. If they cannot be multiplied together, we say their product is not defined. So let's look at these first two. We have P and Q, and we're looking at the two inside numbers here. So if I write them underneath, I see that 3 and 3 are the same. So I'm going to cross those two out, and the new matrix, or the product matrix that I'm going to have, would be a 2 by 2. Okay, next one, we have another dimensions for P and Q, and I'm going to circle the two inside numbers. Notice they're not the same, so this one cannot be multiplied together, and the product is not defined. We can't do that. Next one, we have P and Q. Here the two inside numbers are the same. So once we say that those are the same, we take the two outside numbers. So it's going to be the rows of the first one and the columns of the second one. So it would be a 3 by 3. And this is kind of confusing here. Let me just do this. If a product is not defined, that means you can't multiply them together. This we can multiply together. All right, let's look at how you multiply matrices together. You take the rows of the first one and you multiply it by the column of the second one. So row 1 multiplied by column 1. So that's what they're doing here. They're taking 1 times 5 and 2 times 7. And then they're just continuing on here. Now, something that helps students sometimes is to write down the row and the column of each blank, and I'll show you when we get down to the example here, but you can just kind of look over that and see how the matrix multiplication works. All right, here are 3 matrices, and we are going to find AB if possible. So the first thing that we need to do is we need to see if we can multiply them together, which means I need to take and see if when I write the dimensions, if the two inside numbers match. So that's what I'm going to do first. A is a 2 rows by 3 columns. B is a 3 rows by 2 columns. So I'm circling these two inside numbers here, and I see that they're the same, so now I can cross those out, and then my product matrix is going to be a 2 by 2. All right, so now what I've done, I'm going to write the matrices next to each other and multiply row 1 by column 1, add their products together, and then continue. Okay, so here are my 2 matrices. Now, I am going to use paper clips just to show you how to line up the row and the columns. You're going to take the rows of the first one and the columns of the second one. So here I'm lining this up, and then the columns of the second one, and then I'm going to multiply. So it's going to be 0 times 5 plus 4 times negative 2 plus 9 times 6. Okay, so this is row 1, column 1. This is row 1, column 2. So I need to slide this over, row of the first one, column of the second one. So now I'm going to say 0 times 1 plus 4 times 7 plus 9 times 0. Okay, now I'm in the second row. So this gets moved, row 2, slide this down, column 1, slide this over. All right, so that's going to be negative 3 times 5 plus, we're adding in between the products, 3 times negative 2 plus 2 times 6. Okay, now I'm in row 2, column 2. So here's row 2, slide it over for column 2. So that's going to be negative 3 times 1 plus 3 times 7 plus 2 times 0. Okay, now you can see how probably it could be really easy to make a mistake. So make sure you're showing me your work. If you have a completely wrong answer, at least I can go back and see what you did wrong. You can look and see patterns here too. You have a 0, negative 3, 0, negative 3, which shows up right here. And then you have a 4, 3 here, 4, 3 here, which shows up here. You have a 9, 2 here, 9, 2 here. And then where do we see the rest of this? Well, we see the 5 and 5 here, and then we see the negative 2, and then we see the 6. And then if we go to the second column, we see the 1, the 7, and the 0. All right, so let's go ahead and simplify this. Okay, so what I've done next is I've just multiplied these out. This is going to be 0, negative 8, 54. Here we're going to get 0, 28, and 0. Next row, negative 15, negative 6, 12. Next row, negative 3, 21, and 0. And then when I simplify all those, I'll have 46, 28, negative 9, and 18. Which is much different. I mean, if I tried to multiply here, it would look like it was undefined. All right, one more thing I want to go over with you is that matrix multiplication is not commutative, and that means that order matters. CA is not the same as AC, and that's not the one thing that I wanted to go over, but I just want to explain that to you. Last thing that we're going to do is we're going to square a matrix, if it's possible. So we're going to try to square C squared. Or we're going to square C, I should say. Here's the matrix C, which means I'm just going to multiply it by itself. And you won't always be able to multiply every matrix by itself. Let's say if you have a matrix that's 2 by 3 and you multiply it by a 2 by 3, these two middle numbers are not the same, so you won't be able to do it there. But this is a 2 by 2, so we have a 2 by 2. We're multiplying it by a 2 by 2, so that is going to give us a product matrix of 2 by 2. All right, so let's write these out here. We have, this is row 1, this is row 2. This is column 1, and column 2. All right, so I'm going to get my paper clips here, and that's going to show, if I want the number in row 1, column 1, I have to take row 1 from the first one, column 1 from the second one. So that means I'm going to take 11 times 11 plus 1 times 12. Okay, now if I want position row 1, column 2, it's going to be 11, is that a negative? Yep, times negative 1 plus 1 times 10. All right, now let's go down. We're in row 2, so I have to slide this down here. And I'm in column 1, so I'm going to slide this over here. And we have 12 times 11 plus 10 times 12. All right, now we want row 2, which is here, column 2, which is here, and I have 12 times negative 1 plus 10 times 10. Okay, now I was just looking this over before I combine everything, and I noticed that I left off a negative 1 here and a negative 1 here, and you may have already caught that. So if you didn't, just put this negative 1 in here and this negative 1 in here. And then when I simplify that, I'm going to multiply these together and then add, and multiply these together. So to get 132 plus 120, and then I'm going to multiply these two individual products here and also here. And then I'm just going to simplify. So my final matrix is going to be 109, negative 21, 252, and 88. Okay, now you have a few matrices to try. Before I turn this off, I'm going to ask you, see if you can solve a riddle. Why was the matrix arrested? And you can just email your answer on Schoology, and the first correct answer will get some candy.